Welcome back, everybody. We are here to continue with our joint logistics track and all the presentations. And next up, we have Zadie Ortiz with DataCrunch Lab here to present about their solution. Take it away, please.
Thank you. Good afternoon. Thanks for the opportunity to present DataCrunch Lab at the Tradewind Member Showcase. My name is Zadie Ortiz, and I am the co-founder and CEO of DataCrunch Lab. Let me tell you a little bit about myself first. I'm a computer engineer by training. I have a PhD in computer science. Started my career as a performance engineer at IBM, and then using modeling and simulation, I built many machine learning models to inform business decisions. What server products to build, what features to include, the amount of memory, storage, compute capacity, virtual capacity, and what workloads would they be able to support, from web servers to databases to high performance computing. And once I saw how we were building from large multi core systems to very small systems like edge servers, in how we were leveraging that data to be able to make decisions, I decided to start a DataCrunch Lab. At DataCrunch Lab, we are on a mission to transform operations with data and AI. We leverage emerging technologies to anticipate logistics needs and coordinate resources to improve mission readiness. We bring analytics to improve the visibility of operations, AI and machine learning to anticipate demand, and then automation to integrate disparate systems. We have a history of providing innovative solutions and have served organizations in the government, financial services, retail, IT, and manufacturing. And this afternoon, I'm going to present a little bit of the solutions that we have built. First of all, the challenge that we are addressing for the Navy in particular is the maintenance of remote systems with sparse communication and limited sharing of logistics information. The US Navy found that it's difficult to understand a system's overall state, logistical needs, and associated future state. So, how might we provide effective logistical support for maintenance operations? These systems, in the last few years, have been instrumented with sensors to determine the condition of the various subsystems. Currently, the sensor data is brought into the shipyard or the maintenance facility, and that data is crunched in there to determine the maintenance needs. However, if an unexpected repair is found during that inspection, the parts and skills labor that is needed will have to be procured and scheduled. Delays may push the maintenance activities outside of the window of availability, causing scheduling conflicts, added costs, and affecting mission readiness. Now, if we think about the unexpected repairs part and think about the best logistics companies like Amazon, we notice that they anticipate their customers' needs to provide the goods that people want. Few years ago, if you order something online, you would have to wait 3 days, a week, or even a month to get something from an online store. Today, I can order most things from Amazon and have it at our doorsteps tomorrow. Why? They're leveraging the data that they have collected over the years. They anticipate what people want or need, and then they bring it closer to where it would be selling. That is the power of logistics planning, and that's what we want to bring the experience to supporting maintenance operations. So our solution is a digital logistics expert assistant that will support the flow of information that is needed to modernize and automate maintenance planning. Through analytics, AI, and automation, the assistant streamlines the process of determining the operating condition of the equipment, the machinery, anticipates the maintenance and logistical support that is needed, and provides that information so that there's time and opportunity to procure new parts, schedule the skilled labor, and optimize processes at the maintenance facilities. Our main end user would be the logistics officer that needs to procure new parts with sufficient lead time. But we would also benefit by providing that information throughout the organization to the maintenance supervisor such that they can also prepare the maintenance facility. An expert assistant that anticipates the maintenance and logistical support needs will fulfill the vision of the joint logistics program, where the vision was to, if we can inform and advise the maintenance managers and operations officers of the pending fault probabilities, then they can execute informed decisions on when to perform maintenance, what tools, people, and parts to have ready, and or which system to select for what mission. So that's the vision that we are fulfilling. We delivered a proof of concept of a key component of the assistant that demonstrated leveraging AI to facilitate the flow of information for logistical support. From the sensor data in the shipboard, ingesting that data to doing a real-time assessment of the system condition, to triggering a service request with the contextual information that was needed to plan the maintenance activities. The prototype, we implemented digital twins to maintain the system's knowledge of self, and included several AI and machine learning models to determine the system condition and anticipate failure. In particular, we implemented prognostics and health management assessments for a Navy frigate characterized by a combined diesel, electric, and gas propulsion plant based on the LM 2500 gas turbine. We implemented data-driven machine learning models to assess the performance of four critical subsystems typically found in the Navy frigates: the gas turbine compressor, the hull, and the propellers. For each of the subsystems, we created data-driven machine learning models to determine the performance degradation, and using techniques such as unsupervised machine learning for anomaly detection, regression-based health assessments to determine the extent of the degradation, and explainable machine learning to aid in problem determination. We are looking to extend the project into programs that may be implementing a shipboard enterprise remote monitoring system to augment the applications in your ERM, such that we create those machine learning models for your whole mechanical and electrical equipment. So of course we need a quad chart to explain the impact and width of that data environment. The goal, of course, is to provide an integrated data environment that modernize maintenance planning with analytics, AI, and automation. The impact is to maximize the operational availability, expedite maintenance operations, and reduce operation cost. And the end user benefit is for the logistics officer. They will be able to procure new parts with sufficient lead time to be delivered when needed, and maintenance facility supervisor to schedule the skilled labor for anticipated maintenance work. Now, let me discuss a few other capabilities that we bring to the table that are also applicable to the logistics problem. The first one is the conversational AI. We pioneered the use of conversational AI to increase the visibility of key performance indicators to make informed business decisions quickly and effectively. That was back in 2017. We created a digital assistant that provides up-to-date, real-time insights into the operations. No need for the operator to learn SQL, just ask in plain English, what is the lead time for the parts on order? We were bringing the data from a backend system, crunch that data, and create the visualizations presented to the user in a user-friendly messaging system like Slack. We won 2 awards for this project from GE, General Electric. We were the grand prize winner. We're very proud of that, and the highest potential value to manufacturers. And we are integrating that into other projects. In the commercial sector, we have created machine learning models for a fintech startup to help consumers become homeowners. The machine learning predicts the probability of approval in a similar fashion that we anticipate system failures. And we also created for them a virtual assistant with conversational AI to help consumers through their process. And another capability that we bring to the table in another project, financial services, we created the data architecture and implemented additional machine learning models to improve operations with an end-to-end AI platform to harness historical data. This one in particular was using cloud computing, but as we have shown, we can work from the edge to all the way to the cloud. To the cloud. Of course, last but not least, I wanted to talk about our capabilities for data readiness for AI development services. That we have the VOA from the JAKE, and these capabilities for services are for data science, data engineering, data architecture, acquisition and curation, doing quality and analysis, doing synthetic data generation and data anonymization, software development, enterprise information management and governance, cloud integration and alignment. We know that there's a lot of data in the logistics area that is not leveraged today. We can help you get started with a data readiness services. You can contact us, Drade at datacrunchlab.com or info at datacrunchlab.com. Our team has the skills and experience to architect, design, and develop highly complex IT solutions based on our education, professional experience in corporate America, and we have established several different partnerships. We are an IBM Silver Business Partner, and also I partner with Red Hat to provide microservices in Kubernetes environments. We have had hands-on experience in cloud computing, leveraging AWS services and Microsoft Azure, and have also joined the NVIDIA developer program. We provide consulting services, integration services, and solution development. So if we would be glad to help with transform the operations with analytics to bring visibility into the operations, AI to anticipate the maintenance needs, and automation to be able to connect all those disparate systems. So thank you very much for the opportunity to share our work with you this afternoon, and reach out to us different venues, info at datacrunchlab.com or via the Tradewin membership. Thank you.
Thank you very much to Zadie and DataCrunch Lab. We will now end this session and have a bit of a longer break than the intended 5 minutes, but we will resume at 2:20 exactly for our next presentation. Thank you very much.
Thank you.